Welcome to my video lecture on testing a population proportion given the sample proportion, which is p hat. On this page I have the general outline for all possible cases for testing the population proportion for you, and you can find this in your PowerPoints. Let's look at a given problem here. So we have, according to a recent poll, 53% of Americans voted for the incumbent president. If a random sample of 100 people results in a 45% vote, test the claim that the actual percentage is 53%. So there is a belief that the population of the Americans that voted for the president is 53%, and you're trying to test that belief. So we'll start with writing the belief, which is the fact that the Americans voted for the incumbent president. The percentage is about 53%. So my P is here 53%. That's the belief. In this case, we want to see if that claim is valid or not. So the counterclaim for that will be not equal to 0.53. So we have the claim, which is the actual percentage of the people that voted for the president 53%. And the counterclaim here will be P is not equal to 53%. The opposing statement. Very good. Now let's write the given information here. I have a random sample of 100 people, so N is equal to 100. And out of those 100, 45% of them we know voted for the president. So my sample percentage, which I label as P hat, is 45%. And my significance level, since it's not given, is 0.05, which corresponds to a confidence level of 95%, or 0.95. But in hypothesis testing, we use alpha much more than the confidence level here. We use the area in the tail rather than the area in the middle of the distribution. Now, our first objective is to set up our null and alternative hypotheses for the hypothesis testing process, HO and H1. The ho and the high, I call it, and my alternative hypotheses, as I've told you, could also be written as H sub A. Some textbooks you see it as H1, some textbooks you see it as H sub A. Now the equality statement always goes to the null hypotheses, the single value, and ultimately, as I've told you before, the goal of hypothesis testing is to reject the null hypotheses. That's the ultimate goal of the hypothesis testing. We want to reject the null hypotheses, and if you can't reject it, you say I failed to reject it, as you've been told, just like the court of law. There's never innocent. It's guilty or not guilty. There's never accepting the null hypothesis. You either reject it or you say I couldn't reject it. There wasn't enough evidence for me to reject it. Anyway, so P is 0.53. That goes to my null hypotheses. The opposing statement, which is the not equal to case, will go to the alternative hypotheses, and that constitutes my first step of my hypothesis testing procedure. So there is my step one. I call it. Your second step of a hypothesis testing procedure would be to construct the test statistics, or to calculate it. So you have that numerical value that's going to help you determine ultimately whether to reject the null hypothesis or not. Now we have a whole bunch of formulas. The one we're going to use to testing a single P is Z equals P hat minus P over the square root of P Q over N. So that's my test statistics. Now here my P hat is 0.45, my P is 0.53, my square root here is P, which is 0.53, times Q. Now Q, remember, is always 1 minus P. In any context, and I've told you this before, back from module 2. So if P is 53%, then Q will be 1 minus 0.53, which is 0.47. So it'd be 0.47 here, divide by the sample size, which is 100. And from here, we're going to find some kind of a numerical value, and we'll have to type that on a spreadsheet. Now, I'm actually going to do that for you. I will type this up on a spreadsheet so you could actually see how it's done. So I'm actually going to specifically select this. I'm going to copy it. I'm going to go to my spreadsheet here. I'm going to paste it. And I'm going to type this on our spreadsheet so you can see how it's typed. There we go. So, and the way you type it is right below. This is what you type, 0.45, don't forget the parentheses, minus 0.53, minus 0.53, then divide by the square root of. You don't need multiple parentheses inside. I write the parentheses because I'm writing it on paper, so you can't just, if you write 0.53 and 0.47 next to each other, it would look like a typo. So when you're writing it with handwriting, you have put parentheses for people to see the distinction, but when you're actually typing it on Excel, you don't need parentheses, you just put 0.53 and then you multiply it by 0.47 divided by 100. And you just need to open and close the parentheses for the square root. That's about it. And you get negative 1.603. Negative 1.603. So negative 1.603. So that becomes my test statistics. Now my rejection region here, I need to construct so I know whether this test statistics is going to allow me to reject the whole null hypothesis or fail to reject, and you determine that by determining if this number falls in the rejection region of the graph you've constructed or not. So let's draw the graph. So it's a normal distribution test because it's a p-test, single p-test. So here's my normal distribution. Now remember, we're going to be dealing with all the way through standard normal distribution here. That's my probability axis. And that's 0. Now 0.53, not equal to 0.53, not equal to 0.53. Now you determine whether you have a one-tail or two-tail test based on the alternative hypothesis that's given to you. Your alternative, I'm going to remind you that your alternative hypothesis here could be either less than, greater than, or not equal to. And it always goes with the direction of the arrow. So this is obviously a left tail test, this is obviously a right tail test, and this is a two-tail test, they call it. Here it's not equal to, so we're going to have a two-tail test here. So we're going to draw the tail areas here. Oh, what was that? So that becomes my rejection region if I do it with yellow. So the two tail areas are my rejection region, and it's always going to be in the tail area. So sometimes one tail, sometimes two tails. So they call this a two-tail test. All right, now your alpha is 0.05. That means the total yellow area here is 0.05. So this is 0.05. And that's 0.05. Combined, that is. So in reality, this is 0.05 divided by 2. This is 0.05 divided by 2. So together they're 0.05. And the idea here is to be able to find these two gatekeepers, I call them, critical values, also they're known. And I need to find that based on just the fact that if that's 0.05 divided by 2 and that's 0.05 divided by 2, how much would that be? Well, you could, I mean, if the both yellow areas is 0.05, then this is 95%. So we all remember that if that's 95% from the previous chapter module, it's 1.96 and minus 1.96. But you could also find it by using the command on Excel. Now, if this area is 0.05 divided by 2, which is 0.025, well then, remember you find a z-score based on the area to the left, not to the right. So if I wanted to find a z-score for this particular z-score here, I would have to type equals norm dot s dot inverse, and I have to type the area to the left of that value, which is 0.975. And if I do that, I'll get 1.96 anyways. So either way, you get the actual value of 1.96, which tells you where the rejection region starts from. Now the question is this test statistics falling in the acceptance region, I call it, or in the rejection region? All right, so I've typed this up for you, so let's move on and actually look at it typed up. So we write the given information. I usually call that step 0. We write the original claim, we write the counterclaim, and then we categorize it under the null and the alternative hypotheses. We've done that, and I have the whole thing for you written here. So you set up your null and alternative. Remember, the null hypothesis always sits first. Equality always goes to the null hypothesis, and then the other one goes to the alternative hypotheses. You really don't need to put the original claim and the counterclaim. I just put it there regardless. You calculate your test statistics afterwards. So your second step will be to calculate some numerical value, and I'll even show you how to type it. And that's your numerical value there, negative 1.6. Then the third step is to construct the so-called rejection region, which you will determine if it's two-tail or one-tail based on the inequality direction in the alternative hypotheses. So since here H1 has the not equal sign next to it, then we're going to have a two-tail test. So you have two tails. The area in both of these tails is 0.05, so the area in each one is half of 0.05. Fantastic. Now I've written all the areas here for you just to know, but you don't need to know that's 0.475. All you need to know if the top area is 0.025, then the bottom area is 0.975, and that's what you need to read the z-value. And that's how you know it's 1.96. Alright, so once you read the z-value, or the critical value in this case, for this step, let me just clean it up a bit. Okay, so once you find the critical values, and once you know your test statistics, all you have to determine is if that test statistics falls in this non-critical value or acceptance region, or does it fall in these red critical value areas. Well, let's see. If that's 0, and that's 1.96, and that's minus 1.96, so I can even draw it on a scale for you. If this is 0, if this is 1.96, and this is minus 1.96, where do you think minus 1.6 would fall? Yep, you're right. It would fall right there. Minus 1.6. So therefore, it's falling into the acceptance region. So it's not in the rejection. Well, if it's not in the rejection, it's not in the red area, then we can't reject it. So what do we say? We fail to reject it. So it looks like whatever claim they made, it said according to a recent poll, 53% of Americans voted for the incumbent president. It looks like we can't reject that statement. So if you can't reject that statement, what does that mean? I mean, it's probably true. So, but you can't say it's true, just like in a court of law, you can't say it's innocent. So you say there wasn't enough evidence for me to reject the original claim. Like you really want to reject it, but you can't because the hypothesis testing telling you couldn't do it. So that will be the final response. So remember, we're going to do the null and alternative, calculate this value, set up a rejection region, and basically decide if you're going to reject or fail to reject. And then draw a conclusion based on that. Thank you.